to another tutorial on data analysis fundamentals brought to you by X Creations. This is lesson 11, where we will be talking on the analysis of variance, popularly known as ANOVA, and we will walk you through the one-way ANOVA analysis in SPSS. In lesson 9, we saw the independent sample t-test. We saw how to check for outliers and how to transform our data if it does not meet the normality assumption. So you might want to take a look at lesson 9. So, as said, ANOVA stands for Analysis of Variance. It is a statistical test used to analyze the difference between the means of more than two groups. When to use ANOVA, the dependent variable must be continuous. The independent variable should consist of at least 3 categorical independent groups. The observations are independent of one another. The data should be approximately normally distributed. The data should not contain any outliers, and there should be homogeneity of variances. Don't worry if during analysis, 1 or 2 of these assumptions are not met. That is what is common seen in data that is obtained from the real world rather than textbook data that everything seems to be perfect. So, ANOVA uses the F-test for statistical significance. This allows for comparison of multiple means at once because the error is calculated for the whole set of comparisons rather than for each individual two-way comparison like it would have been the case with the t-test. The F-test compares the variance in each group mean from the overall group variance. If the variance within groups is smaller than the variance between groups, the F-test will find a higher F value and therefore a higher likelihood that the difference observed is real and not due to chance alone. There are 2 types of ANOVA. We have the one-way ANOVA, which has just one independent variable, and we have the two-way ANOVA, which has 2 independent variables. So if you have 2 independent variables, you will be using the two-way ANOVA, and if you have 1 independent variable, you would be using the one-way ANOVA. So we are going to demonstrate the one-way ANOVA, and we have a data set containing the number of times pregnant women took Fansidar. That is our independent variable, which has independent categories. It's either you took Fansidar no time, 1 time, 2 times, 3 times, 4 times, or more, and the birth weight of their babies, which is measured in kilograms. Of course, that is our dependent variable. Good, let us see this in SPSS. Here we go. We have our data sets. We have 2 variables. Our independent variable consists of the number of times the women took Fansidar. Of course, Fansidar is a prophylactic malaria drug that is given to pregnant women, especially in sub-Saharan Africa, to prevent malaria, since malaria is considered a threat to life, especially during pregnancy. So we want to know if the number of times a pregnant woman took Fansidar can affect the baby's weight. So in the previous lessons, we have shown you how to test for the assumptions. Of course, you should know here that we have independence of observations. For example, if you took Fansidar 3 times, it could only be 3 times. You could not take Fansidar 3 times and then take it again 2 times. So there is independence of observations, and our data is we have 150 samples, which is good. And to test for normality, Shapiro-Wilks test, to test for the homogeneity of variance, you will see that here. So we will go to analyze, we come to compare means, we go to one-way ANOVA. We send our dependent variable to the dependent list, and we send our independent variable to the factor. Come over to post-hoc and we check Turkey. This is the test that will tell us which particular group or which particular groups have differences if there is a significance. Click on continue, we come to options, we click on descriptive, and we check homogeneity of variance, and then click on continue, and then click OK. So here we have the descriptives, we have the various frequencies and the mean, standard deviation, standard error, and the 95% confidence interval. We have our test of the homogeneity of variances, which is greater than 0.05, which tells us that indeed there is homogeneity of variances. So we have nothing to worry about. And then we come down to our ANOVA. We see that the significance, there is actually a difference between the groups. Whether you took fancy that no time, one time, two times, three times, or not, or more, there is a difference between the groups. But then there is a difference between which particular groups we do not know. So we now have to come down to our post-hoc test, where we use the turkey and we check for any significance. So we come to the significance column and we're looking for anyone that is significant. Okay, we have 0.018 here, which is significant, and we see that it's between those who took Fansida 2 times and 3 times. So there's a significant difference between the birth weight of the pregnant women who took Fansida 2 times and 3 times, and you can see that here that we have 3 times and 2 times, and it's significant. So there's a significant difference, and then we can go to the mean weight to see which of those groups had a higher weight. So if you look at the mean, 2 times we have 3.4, 3 times we have 3.1. Which means that the pregnant women who took Fansida 2 times gave birth to children with better or higher birth weight than those who took Fansida 3 times. Interesting. Okay, that is it. And one way another, we will be looking forward to seeing you in the next tutorial, where we will talk on the analysis of covariance and cover. Thank you for watching. Remember to hit the like button and subscribe to our channel.